Hey everyone, how's it going? It's Russ here, and today we're going to learn all about what it takes to make an NFT project from scratch. And we're going to break it down into 5 different categories. The first one is the art of the NFT, then the metadata of the NFT. We'll get into what exactly that means. The smart contract that actually mints the NFTs, the minting application that lets you use the smart contract from a normal website, and the whitelist to make sure that the people that you want to be able to mint it for free or mint it for a reduced cost are able to actually do so. And we're going to use this NFT project that I coded up myself as an example to explain some of these concepts. This is called Consensus Comics because it was released in the week that consensus mechanisms changed on Ethereum with the switch to proof of stake, the merge. Now let's start with the art. Generally, you can make this whatever you want to on an NFT, but for this example, we're going to use this sort of generative NFT profile picture collection to explain the way that these are generated and actually created randomly. Generally, these types of NFTs are made with a number of layers that are stacked on top of each other to make the art. Take a look at these NFTs here. You can see it's distinctly made in 3 different layers. First, we have the head layer, then we have the body layer behind that, and then the background layer behind that. And so what you can do is you can create many different versions of these different layers and have code stitch it all together. And you can get a behind the scenes look at these layers here. Take a look at this. Like I said, there's 3 different layers: backgrounds, bodies, and heads. And each different head is just the head layer. So you can have a sort of a folder full of a bunch of different head elements here. And the same goes for bodies, every single body that is in the collection, as well as the different backgrounds that could be that final layer. Now, most people will do this by writing a program in JavaScript, one of the most popular programming languages in the world, that sort of takes each of these individual files and stacks them on top of themselves. You can write this code customly, or you can use an engine that's been pre-developed to do that. Lots of people use an engine called the Hashlips art engine, and that is really helpful for making this exact kind of PFP NFT collection because it also formats the metadata, but we'll get into that in a second. And after you run that code, it will stack these images on top of themselves and create however many you want. And you can also do things to make sure that you don't get any repeats of the same sort of layer configurations. So now we've got all of the art. Now we need to focus on the metadata. But first, what is metadata? Well, actually, this is all of the information that various websites and different applications might need to be able to find the information about the NFT itself. These NFTs don't just point to an image that's stored somewhere. It also points to the name and the description of the collection, as well as which number of the collection it is. All of these details about the image that maybe OpenSea would display are stored inside of that metadata, which is typically stored in a file called a JSON file or a JavaScript object notation. So this is essentially just a format that a lot of people know how to work with so that they can build applications that use that data and are able to grab the values that are inside of that data to be able to display your NFT. And here's an example of one of those metadata files. You can see here it has a whole bunch of different fields that are filled out that will give that information. We have a name and a description, an image, an edition number, a date, and then attributes. And all of this data will be used by applications like OpenSea to be able to display the right information for the user that is either buying or selling the NFT. Now, we're going to focus here in the next little bit on one very important spot in this metadata file, which is the image tag here. We can see here image and then what looks like a big jarble of a bunch of letters and characters. Doesn't really make a whole lot of sense, but it will. This image property inside of the metadata is what OpenSea is going to look at to display your image, right? Your NFT isn't the image itself. It's kind of a pointer to an image that's stored somewhere else. Now, this could be even on Google Drive or something as simple as that. But most people don't like to store NFT images on Google Drive because, hey, maybe your access to that drive could change in the future and then your NFT wouldn't display properly, which would be a pain, right? You want some sort of guarantee that your NFT is going to stay the same, which is why a lot of people turn to something called IPFS, which stands for Interplanetary File System, which is like a decentralized network of people that are all storing that data for you in a way that it can't be changed. So because I've stored all of these images on IPFS as well as the metadata on IPFS, when I take this link, which is inside of the metadata, we can go to a web browser, and with a little bit of a change to give it a gateway, we can see that the metadata that gave us this link describes the very image that metadata is describing, right? We have an alien here with a mayor body and an orange background, right? So we should see when we flip back to the metadata, okay, we've got orange pixels, the background, the mayor body, and the alien head, so it matches perfectly. And this is where we have to get into the world of smart contracts, because how does OpenSea even know where to look for this metadata file, which will then give us all this information, including that link to where to find the image? Well, that information about where to find the metadata is actually stored inside of the NFT smart contract. You might already know that when you deploy a contract and you verify it, Etherscan will actually show you a user interface where you can read information about that smart contract. Now, we're looking for a very specific function here called token URI. Now, for token URI, it will give you a link to where you can find that metadata for any given token in the NFT collection. So if I go into here to token URI and I say, okay, for token number 3 of this collection, where can I find that metadata? I'll query it, and then we're going to get a very similar string of letters and characters that we just saw you can sort of get by going to this link in your web browser with a couple changes to give it an IPFS gateway. So each individual token will give you a different IPFS link so that it's giving you the right metadata. Remember, metadata is stored in this JSON object, JavaScript object notation. So you can query for any token and get the information on where you can find the rest of the information for the NFT. And that's exactly what OpenSea does, right? It's a little bit more complex and a little bit faster, but they, for every token that exists in your contract, basically go to this token URI call on your function, and they say, okay, for token number 6, this is what I want to display on the website. I'm going to query it. I'm going to look at the link. I'm going to get all that information, and inside of that information, they'll be able to find out where the image is stored. In terms of the actual Solidity code, we're not going to get too deep into that in this video, but just know that there are a number of different pre-made contracts made by OpenZeppelin so that people can sort of bring in really common contracts and functions from those contracts and know that OpenZeppelin's had them audited and checked to make sure that they're safe, so you can get this really strong functionality inside of your application without having to rewrite the whole thing. And that's exactly what I've done here, grabbing the ERC721, the typical NFT token, grabbing their Solidity file so that I can use some of their functions to make my NFT. So now we've made our NFT collection, but how are people actually going to mint it? Well, we were just on Etherscan, and you might know that you can read information from the contract, but you can also write information, like here's a mint function inside the contract, and if we called this function, we could mint one of these NFTs. But it's not the best user interface or user experience for people to go to Etherscan to mint your NFT, which is why you might want to build a specific minting application or front-end application that the user can go to mint their token, instead of having to go to Etherscan, a little bit more complex. And that's exactly what I've done here with consensuscomics.com, where you can mint this NFT. Most people watching this are probably on the whitelist through something, so you can probably mint one of these for free if you haven't already done so. And you can see here that it's a relatively basic site. We've got a preview of the images, and then we've got a mint ability and a whitelist mint. Up here, we've got your wallet connect functionality, and that's using something called Rainbow Kit, which is a great way to connect your front-end application to the blockchain. And from here, you can again change how many you want to mint, and you can click this button to mint, and using something called WagMe hooks, which is a way that you can sort of plug into the blockchain very easily if you're building a React app, which is a very common front-end application framework. You can actually very easily choose a function on the blockchain that you want to do, which in our case is the mint function, and connect it to a button here as long as you have your wallet connected. So that's how you would make a front-end application to interact with your NFT contract. And the last thing I'm going to talk about is whitelist functionality. And this is something that I learned the hard way because I wanted to make this as an NFT collection that was free for all of my friends to collect just for fun. And I released the contract, put it onto the blockchain, and then instantly a whole army of NFT bots minted out the entire collection, all 1,000 of them. Because it was a free mint, all they had to pay was gas. And the bots thought, hey, if we mint this and these end up being worth something, well, hey, maybe we can make a little bit of money. So that's why on the second iteration of the contract, I've made a whitelist. And there are a couple of different ways that you can do this. This is the old contract, the old NFT collection, the one that was botted here. I put that in the title on OpenSea. You can see all 1,000 of them were like instantly minted. So it's pretty wild, which is why you're going to need a whitelist. Now, the thing with whitelists is you could have a list of a whole bunch of different addresses that you want to be able to mint it for free, but you have to store that information somewhere, that list of addresses. And if it's a very long list of addresses, maybe 1,000, 2,000 addresses that you want to have whitelisted, well, that gets pretty expensive because the more data that you want to store on the blockchain, which is what you'd have to do in order to make this whitelist work. If you just have a big list of addresses, well, it gets more expensive, right? You have to pay a higher transaction fee or a higher gas fee to store all of that information. But there is a way around it. You can actually make similar whitelist functionality for far less gas using something called a Merkle tree, which sounds super technical, but we're going to keep it very simple right here. For this example, each of these little diamonds here are individual Ethereum wallet addresses that you want to be on a whitelist. Now, instead of storing all of these on the blockchain, which is very, very expensive, we can use some special cryptographic hashing, like some cryptography magic, and using all of these individual wallet addresses as inputs, we can create something called a Merkle root, which is sort of looks like a wallet address, but inside of that information that's stored there in all of those letters and numbers, that information is generated by each individual wallet address. And if you add another wallet or change one of the wallets, that root's going to change entirely and be something totally different. Now, using this information, you can just store the root on chain, the root inside of the contract, and everybody who's minting can, with again some cryptographic magic, show a proof that their wallet address that they're minting from is one of the ones that went into creating the Merkle root that's actually stored on chain. So hopefully that didn't get too in the weeds for you, but I just thought I'd make this video to give you a better idea of everything that goes into making an NFT project and some of the things behind the scenes that you might not have taken a look at before. If you have any questions, let me know down in the comments or send me a DM on Twitter. Russ Matthews with an underscore at the end is my Twitter handle, so you can reach out there. But with all that said, thanks so much for watching, everybody, and I'll see you next time.